Thank you, Madam Chairman. Um, After listening to the earlier presentations, I thought that what what I would do here today would probably be a fitting sort of support to all of that. And in fact, what my intention is to look at this issue, not of sick, as from a sick building syndrome point of view, but more so from that of a sick building, which results from our trying to create space within which to live and occupy. Once man cease being nomadic and settle down to more permanent and located state of existence, the seeds of artificial environments, which really is the thesis here, were sown. It was over some 7,000 years ago that man first attempted to alter the Earth's terrain and explore more ways of protecting himself from the impacts of the natural environment by manipulating various elements of that environment to his advantage. While the term artificial environments would hardly have been imagined at that time, and presently conjures up in our minds images of science fiction and advanced technologies, a quick shift in our thinking would soon lead us to the conclusion that while the term is more closely associated with today's highly technological world, it would also have been as applicable 7,000 years ago when man started to protect himself from the elements with what would have been, at that time, advanced technology. What this would suggest is that at any point in our historical development thereafter, we were attempting or have been trying since to find ways of creating appropriate artificial environments to comfortably accommodate the various activities with which we may be engaged. While our earliest predecessors would have been struggling to construct and maintain rainproof roofs over simple primitive structures, today we simply ask Siri to alter the temperature and humidity of our homes before we arrive, and to commence the process of cooking a pre-prepared meal in readiness for us to consume as soon as we reach home. Or we ask Alexa to switch on a pattern of lighting to create a desired mood for our state of mind on arrival, or perhaps in an attempt to fool would-be burglars that we are at home. We may even request the robot vacuum cleaner to sanitize and vacuum our home before we reach. But who would consider associating sick building issues with the resulting headaches and stress when a homeowner discovers that a burglar has hacked into his Echoes program and requested that the doors of our house be unlocked, or when our robot vacuum cleaner did the opposite to what we requested? These extreme examples sort of force us to consider expanding our notions of sick buildings and ultimately the sick building syndrome. Regrettably, most of our discussions about sick buildings have generally been confined to the design and performance of HVAC systems and their maintenance, but the discussion about sick buildings needs to be expanded to include a host of other architectural and non-architectural design issues, which determine the quality of the environments within which people would be accommodated, as well as the impact these issues will have on the state of well-being of the occupants of these created environments. In our efforts to control the natural environment with the development of artificial environments, we have always had to combat the issues now defined as sick building issues, and which in earlier days, while impacting us, we probably did not label as sick building problems, nor did we complain as much as we seem to do today. The difference perhaps was that we were more personally involved in the creation of those environments than we are today, where so little is done by our own efforts that there's always someone else or something else to blame. When our foreparents complained of catching colds from the air drafts infiltrating the chattel house through the louvers and the windows and doors, the response to that problem was a quick blocking of the louvers with whatever paper could be found. That same solution also aborted the ingress of driving rain. But despite these issues, the louver still remains one of the most sensible environmental responses to the more urgent need for cross-ventilation in naturally ventilated spaces. As a perpetual student of architecture, I remain convinced that whatever attempts we make at creating artificial environments, they have always been limited or expanded by the most current technologies available to us at that particular point in time. Our challenge in creating these environments in a healthy and sustainable way lies with the choices of the systems and materials which best fit the particular needs, including concerns for sustainability, followed by caring and careful management of whatever installations we make. But while, as mentioned earlier, our conversations are mainly focused on the condition and performance of mechanical HVAC systems because of their popularly perceived significant contribution to the current sick building issue, there are a number of other factors which require from us a more focused view with respect to the known or unknown contributions they make to the problem. These would include building location and site planning issues, psychological impact of design quality of interior spaces, VOC emissions from materials specified and installed in built structures, dust pollutants and VOCs remaining in completed buildings as a result of construction activities, VOC emissions from various furnishing items which we bring into the buildings, lighting quality and related audio and electromagnetic emissions from light fixtures and fittings, moisture intrusion into buildings with resulting associated problems, noise emissions from various pieces of electrical and mechanical equipment installed in buildings. What I'm trying to do here is to broaden that sort of base of what we try to talk about when we speak about environments that are not pleasant. So I'm talking more about sick buildings than about the syndrome. The building has to be sick to get to the point where you have a sick building syndrome. Building location and site planning. These issues for concern in the early life of a building, which I call birthing pains, tend not to be given as much attention in this early stage of a project as they ought to. Sites are generally selected for every other reason except concerns for the impact of the environment that will surround them. Naturally ventilated schools are located in close proximity to industrial plants emitting pollutants. Office buildings are located in adjacent to garbage disposal sites. Hospitals are developed in areas with existing high levels of noise pollution. Sewage treatment plants are located in close proximity to tourist accommodation, and the reverse sometimes occurs. The health issues later to be associated with these site locations are seldom given serious consideration when the sites are being selected, although it might be thought that these sorts of considerations would be high on the list of site selection criteria. Site planning is another issue associated with siting of buildings. The location of buildings on a site in a particular way can impact the quality of the interior environment of the building. The orientation of the building can have certain impacts upon ventilation, sunlight penetration, and visual connections to the exterior. Location and design of site installations such as car parking can also impact the interior environment of a building as well. Vehicle parking areas located upwind from naturally ventilated buildings can result in unwanted vehicle exhaust fumes and also enhance the heat penetrating the building's interior. Whether the site is green landscaped, along with the quantity and quality of this landscaping, can make a significant difference to the general environment within and around the building. Recent research has indicated that the health benefits to be derived from well-planned landscaped environments, visually and physically accessible to a building's occupants, are far more significant than we may imagine. This concept is currently being utilized with much vigor in Singapore, as they clearly understand its value to the well-being of their citizens and visitors. How we also use landscaping to screen and filter the impacts of adjacent properties can greatly enhance the quality of the environment on the properties we are designing. The psychological impact of design quality of interior spaces. The human experience of space can be impacted by spatial geometries and proportions of space, visual connections with the exterior from the space, the quality of the interior finishes and decoration of the space. Spaces we occupy can range from being cubical in shape to cylindrical and spherical, along with many other free-form shapes in between. Our responses to these various shapes are dependent upon the proportions given these various forms, from feeling depressingly dwarfed by shaft-like shapes through the spiritually uplifting soaring heights of grand cathedrals, back down to the depressingly crushing linear expanse of the drab concrete levels of an elevated car park. A wide range of human emotions are affected by these different shapes and their proportions as occupants experience these various spaces. While it is generally accepted that connections with the natural environment, both physical and visual, have some impact on the well-being of humans, it has in recent times been scientifically established that these connections are a most necessary part of our well-being. This has led some research psychologists to associate this apparent connection, which is now observed as being universally common to all cultures, with our close links with nature from our primordial past. Spaces that are generally preferred by us all are those with daylight penetration and window and door installations which allow visual contact with the natural environment outside the spaces we occupy. And better yet, spaces that seem to be seamlessly integrated into adjacent landscape areas, blend the two into one. The quality of finishes and decorations applied to spaces can be uplifting or depressing. How we cover walls and floors and ceilings, and how we install artwork and other decorative items such as rugs and upholstery either bring life to a space or render the space displeasing. Recognition of the value of nature in the form of plant life is now so important that every effort is being made to bring this aspect of the natural environment into the interiors of buildings. These installations can now be found in open plan offices, schools and hospitals, spaces which are occupied by people for long periods of time in any day. The positive qualities of these installations tend to offset other negative impacts that may present in built environments. VOC emissions from materials specified and installed in buildings. All of our efforts to create spaces with high aesthetic value and positive psychological inputs can be significantly neutralized by the negative qualities of the various materials we specify for use and ultimately install in the construction of the buildings we design. As responsible architects and designers, we have to ensure that the materials we use in the construction and outfitting of buildings do not eventually release silent and invisible demons for the spatial quality of these buildings. Commonly used materials of construction which can be problematic for completed and occupied buildings are termite-treated wood products, engineered wood products, chipboards, plywood, and other particle boards, adhesives and glues used for joining wood products, and cements used in the fastening of laminates and wallpaper to various substrates. Adhesives used in the installation of carpets and vinyl floor products and wallpapers. Adhesives used in the manufacture of carpet products long before they get to or installing them. Glazing compounds and sealants. Acoustic sealing materials. Paints and other synthetic wet applied wall and ceiling decorative finishes. Exposed insulation products. Many of the problems generated by these materials and installations are usually silently released VOCs, which tend to be not immediately evident. But as architects, we are expected to be diligent in our research and in our review of the materials composition of the various products we will specify, to ensure that these silently present demons are either absent or present only in quantities below those permitted by universally recognized and accepted standards. Some of these demons will remain lurking in the background for extended periods of time before later imposing their impact upon the users of our artificially created environments. But this possibility should not be allowed to escape our attention during product review. Construction dust pollutants and VOCs remaining in completed buildings. During construction of buildings by traditional methods, much dust is generated by many activities, and this dust remains in spaces within the building and on various elements of the construction, which would not normally be cleaned, except the contractor has a determination to follow given specifications for cleaning, or is extremely diligent about the way he works and exhibits some pride in what he does. Dust remains on and in all forms of that work, on the T-bar suspension systems, ceiling suspension systems, above all forms of suspended ceiling systems, and generally on all vertical and horizontal surfaces, whether exposed or hidden. This problem is generally made worse by the failure of the contractor to properly store materials being used on the job, or by inappropriate sequencing of the construction works, which causes various elements of construction to be present on the site well before they are needed for installation. The problem is worsened by the contractor's failure to carry out daily and continuous cleaning of the site, both internally and externally, to eliminate or minimize the presence of debris and dust. Other construction materials which may be responsible for the presence of VOCs in completed buildings include cleaning agents used by the contractor during various stages of the work. Various adhesives and glues routinely used in plumbing and carpentry and joinery installations. Various retarding and hardening concrete additives. Cleaning agents used in the final cleanup of the building before handover. The impact of many of these chemicals is seldom given any serious consideration and may tend to slip into the realm of not so important issues, particularly as the project comes to completion. As an example, the contractor generally subcontracts the final cleaning of the building to specialist agencies outside of his total control. And this can sometimes lead to the introduction of dangerous cleaning chemicals into the building's environment at the worst moment. Because soon after handover, there's an invasion of occupancy. So unless there is a stringent adherence to a stringent cleaning specification forming part of the contractor's contract, these could become real issues. VOC emissions from various loose furnishings items placed in the building. Once various loose furnishing items are brought into a building to outfit the building for use, VOC emissions similar to those described earlier as being present during construction add further demons to the problem. All of our concerns about adhesives and glues and materials composition resurface and need to be given the same attention as at the building construction stage. Although this is normally the work and responsibility of interior designers, the same research and review of applicable specifications is necessary at the selection stage of the furnishings for the building to ensure that VOC issues are eliminated or minimized. Performance specifications for rugs and carpeting and drapes and blinds across the artwork and fabrics and patterns of upholstery all require serious scrutiny before products can be selected for use in the interiors of buildings. Lighting quality and related audio and electromagnetic emissions from light fixtures and fittings. Apart from window day lighting of buildings which may not adequately satisfy the lighting levels required for task work, the lighting in buildings is generally provided by electrical means. While the optimum levels can be readily predetermined and suitable fixtures selected and installed to satisfy these levels, there can be occasions when the quality of this lighting can be problematic. Flickering lights, even when only barely discernible, may have some impact on the users of the lighted space. Also, the sometimes barely audible continuous noises emitted by some light fixtures and fittings may affect some users of the space. Are we quite sure that we understand the health impact these issues may have on the users of the space? We as architects, along with supporting lighting consultants and electrical engineers, would want to be looking at these issues more seriously. Moisture intrusion into buildings with resulting associated problems. The intrusion of moisture into buildings generally occurs because of defects of design and or construction. Moisture enters buildings through unsealed grade slabs, inadequately sealed cellars, poorly designed and or installed windows and doors, and leaking roofs of all shapes and construction types. Moisture also enters buildings as a result of unsatisfactory plumbing and air conditioning installations, which are generally responsible for slow leaks in hidden places. The main problem resulting from the presence of moisture is obviously, as was referenced before, the growth of mold. Wherever there is prolonged existence of moisture, particularly in areas of low lighting, the growth of mold becomes evident. The health impacts of the presence of mold, I'm sure, will be and has been already discussed by other presenters. So our interest here is architectural, and is about eliminating the conditions that encourage the growth of mold while designing, specifying, and constructing buildings. Building waterproofing issues are usually associated with the junctions between two different materials and the performance of these junctions when subjected to wet conditions such as rain and condensation. On the exterior of a building, there are any number of these junctions, and seal joining of these different materials involved can be a challenge for both designers and contractors. Good solutions are usually the result of excellent design detailing, followed by faithful construction execution of the design details. Contrary to popular belief, this is the area of architectural design which occupies a significant portion of the architect's work on a building and requires a great deal of knowledge and experience about construction. We could dedicate an entire workshop to this particular aspect of construction. Noise and electronic emissions from electrical and mechanical equipment installed in buildings. Loud and or barely audible noises and electromagnetic emissions from various pieces of equipment installed in buildings cannot be ignored. We are growing so used to noise pollution because of the excessive decibel levels present in our normal daily lives that we tend to ignore and discount the impact of noise as a potential health issue. It takes a power outage to remind us of the quantity of noise which engulfs us. Cell phones and computers have so become a part of our lives that we never think of the damage that can be done to our health by the various electromagnetic waves emitted from these appliances. Recent studies have clearly shown that significant damage can be done to our well-being by these emissions. While these studies have generally focused on mobile appliances, there are a number of permanent pieces of equipment installed in buildings which may also be emitting these barely audible noises or electromagnetic waves and may be contributing a lot more to the sick building issue than we imagine. This equipment ranges from air conditioning equipment through electric switchgear, transformers, workstation computers, and computer servers and UPSs. Although these installations are not normally the architect's responsible, in our traditional role as project leaders, architects will have an interest in the performance of these installations as well as their negative impacts on the occupants of the building. So basically, those are the issues which, as architects, I think we would be concerned about as it relates to the sick building issue, and not the syndrome, but to the issue of sick buildings. So in wrapping up, what after all of the elements of the creation of artificial environments has been satisfactorily attended, there still remains a subset of the building's population experiencing sick building syndrome. Would we still describe the building as a sick building? What if there exists in a building unreported and undiscerned internal environmental quality issues, and none of the building's population expresses sick building syndrome complaints? How will we determine that the building is a sick building? And at what point do we describe a building as being so sick that we evacuate and abandon the building? And what about the future of artificial environments? Where new and sophisticated advanced technologies now permit us to develop environments internally and externally that are so precisely managed and manipulated by artificial intelligence that we totally relinquish our control of these environments to this intelligence with a belief and trust that it will always make decisions in our interests. I'm going to leave you with that question. Thank you.